Okay, good afternoon. Today we are going to start our next point is coordinate or dative bond. We already discussed some important terms which are used in coordination chemistry. So after that the next term is coordinate or dative bond. Okay, you familiar with number of different types of bonds, covalent bond, ionic bond, metallic bond. Same as there is another special class of or special type of bond is coordinate or dative bond. What is the meaning of that bond? You know, any bond is formed between two atoms. Okay, so actually bond is nothing, it is the force which held the two nuclei with each other called as bond, and different forces depending on sharing of electron with each other, they divided into different types: covalent, ionic, metallic, and next one is coordinate bond. So in coordination compounds, the bond present between metal and ligand is coordinate or dative bond. What is the definition? What is the meaning of that? When any two atoms which are linked together, the bond which is formed between them in a such way that the electron are donated or shared by only one atom out of the two atoms which are linked together, called as coordinate bond. That means suppose we have A plus B, there are two atoms, but here the condition is one of the atom has the pair of electrons which is excess or extra field orbital, and another side the another atom has empty orbital, and you know any orbital needs two electrons to fulfill it. So the two electrons are shared by only one atom and the formation of bond between them. Okay, so this bond is not a covalent, it is a type of covalent, but it is a coordinate bond, means both the electrons coming from B atom, that means it is indicated or represented as this arrow in a parenthesis, that means in a bracket, not a square bracket, it is in a bracket, we call it as a parenthesis, and the arrow indicated this way. So that is the meaning of this arrow or this bond is the flow of electron from only from one side, and after once electrons are shared, both the atoms equally share this electron with each other, so the electrons stay between the two nuclei of the A and B. So here is the coordination. So this type of bond is called as coordinate bond, and in notes the definition is given to you. What it is? A special type of bond in which what happen, the shared electrons are donated by only one atom which are linked together, out of two which are linked together. जे दोन ॲटम असतात फॉर्म झालेले की बॉन्ड फॉर्मेशन ज्या दोन ॲटममध्ये झालेलं असेल त्याच्यातला एकाच ॲटमने इलेक्ट्रॉन डोनेट केले आणि डोनेशन केल्यानंतर मग ते इक्वली काय झाले दोघांनी शेअर्ड केले, सो कॉल्ड ॲज डेटिव्ह बॉन्ड. ओके, नेक्स्ट टर्म इज कोऑर्डिनेशन नंबर. Coordination number. Okay, it is represented as Cn, coordination number. Okay, so coordination number means what? Once complex is formed, we see, suppose we consider Cu NH3 2 plus complex. Okay, so in a square bracket the central metal atom or ion is present. This central metal atom or ion is surrounded by the different types of ion or molecules. Here it is the molecule, NH3 is the molecule. In given example, the Cu is surrounded by 4 NH3 molecules, means the Cu attached by 4 NH3 molecule. So it is the number of ligands which are directly attached to the central metal atom or ion called as coordination number. This pair called as coordination pair, and how many ligands are present in a square bracket, that is the coordination number of the central metal atom or ion. Okay, so here the Cu has +2 oxidation state and their coordination number is 4 because 4 NH3 molecules are attached. Suppose you consider K4 FeCN6. So here K4 is the cation which is outside of the square bracket, but inside the square bracket how many cyanide ions are present? 6 cyanide ions are present which are directly attached to this Fe ion, Fe2 plus ion, because Fe has +2 oxidation state. How to calculate oxidation state? When we are going to discuss the nomenclature topic, that time we will well discuss in detail how to calculate the oxidation states. Okay. So here Fe present in which oxidation state? +2 oxidation state. But this 4 number is not coordination number, because how many cations present or how many anions are present is not a coordination number. This will well explained by our second chapter is Werner's theory. Okay. So only think about this square. This is the complex, and in complex how many ligands, how many cyanide ions are present? 6 cyanide ions are present. So here the coordination number is 6. Coordination number is 6. So this is the number, the how many molecule or ions or atoms directly attached to the central atom or ion called as coordination number. Okay, so basically 2, 3, 4, 5 and 6 coordination numbers are observed in coordination compounds. But out of that 4 and 6 coordination complexes are mostly observed, because number of metals form 4 coordination number or 6 coordination number, or some form both 4 coordination number complexes as well as 6 coordination number complexes. So how many maximum number of ligands attached to the central atom or ion, it depends on their stability. So a ligand try to attach to the central atom or ion till they get the complex get the stability in a equilibrium conditions. So that will decide how many ligands are attached. So basically we observe 2, 3, 4, 5 and 6 ligands, 6 coordination number, but basically these two are observed. Okay, so 4 coordination number, 6 coordination number. So here coordination number 6, here is a coordination number is 4. Suppose you consider so in given here is a silver present in +1 oxidation state, but here how many ligands are attached directly to the Cl? There are 2, so coordination number is 2. So different type of metal atom or ion has different coordination number. It depends on their stability in a equilibrium condition. So this is all about the remaining 2 terms, coordination number and coordinate bond. Okay. So next we move to our next topic is, up to this we saw there are different terms are used in coordination chemistry. Okay, so different terms are used, so different types of complexes are formed in different set of conditions. So next point is we are going to calculate, understand formation constant. Formation constant means how complexes are formed and in which conditions complexes are stable or not, that we will be going to discuss in detail. Okay, basically that will explain inert and liable complex. Inert and liable complex. Okay, so inert and liable. Inert means basically their meaning is there is a less reactive, and liable means more reactive. So it is depends on chemical reaction mechanism of inorganic complexes. Okay, reaction mechanism also exists in coordination complexes, same as organic chemistry. So formation constant. Okay, so basically in given complexes there are 2 entities. One is metal, another is ligand. We know metal is present, ligand is present. Role of ligand is donate the electron pair, and role of metal is acceptor. So metal is acceptor and ligand is donor. Okay, so acceptor means accept the electron pair from ligand, donor to donate the electron pair to the metal. So in acid base reaction, you know the Arrhenius theory, you know the Lewis theory, you know the Lowry-Bronsted theory. According to Lewis theory, a substance which are capable to donate the electron pair called as base. So here ligand acts as a Lewis base, okay, and other side metal acts as a Lewis acid. So basically acid base reaction happen between the metal and ligand, okay, and you know when acid base reaction is powerful, it depends on strength of acid and strength of base. Same thing is here. How much stronger bond formed between metal and ligand, it depends on their acidic and basic nature. Acidic basic nature means what? If any acid which is stronger, so their role is accept the electron powerfully, so it is a stronger acid. Which is a stronger base? Any base which donate the electron pair powerfully, means strength of acid increases, strength of base increases, the acid base reaction increases, their formation is increases. Same thing is here. Ability of ligand to donate the electron, that will decide the stability of the complex, as well as ability to accept the electron pair of metal also decide the stability of the complex. So both will responsible for the formation of constant or stable compounds. So Ml bond here, for Ml bond is formed, metal ligand, you know this is a coordinate bond, okay. So strength of bond depends on their acidic and basic character of metal and ligand. Using this phenomenon, the formation constant are divided into two types: thermodynamically constant and second kinetic. Thermodynamic and kinetic. Thermo means temperature, okay, and there is a heat, okay, heat related to the any work, mechanical work or any chemical reaction. So thermodynamic condition, and you know if the reaction, if the any reaction which is takes place a particular set of conditions, means temperature, pressure and volume, and reaches to the equilibrium point. Equilibrium point means what? Here is the reactant side, here is the product side, okay. So basically we move from reactant to product side till we reaches the equilibrium. We reaches the equilibrium. आता बघा तुमच्याकडे एक कॅन आहे, हा एक दुसरा कॅन आहे, okay, and if you join together, हे एकमेकांना काय केले, join केलेले. If you put water here, okay, this water goes flow here. How much time this reaction, this process takes place? Till the water comes up to here. Once the water level is like that, if you add water here, there is no water flow from this side to this side, because already both sides reaches to the equilibrium point. Same thing in chemical reactions. In which time of how much time reaction takes place, it depends on to reaches the equilibrium point. Okay, so reaches the equilibrium point, it depends on two way. First way thermodynamically, second way kinetically. Thermodynamically means what? A particular set of condition, means temperature, pressure and volume. If the reaction reaches at the equilibrium point, so acid base reaction equilibrium point or metal ligand reaction reaches to the equilibrium point, means the complex formation takes place. After that there is no further complex formation. Complex 100% form, and in that condition, if complex is stable or not, that is the thermodynamic. If complex is stable, we said it is a thermodynamically stable conditions. And what is the kinetical? You know what is the kinetic? In physical, you know the kinetics. Kinetics means what? It is just related to the speed and mechanism. Rate and speed and mechanism will decide if the metal and ligand reaches to the equilibrium point. So here the rate is important. Rate means speed, and second one is mechanism. Mechanism means it is a just hypothetical picture which is clearly indicate how atom molecules react with each other and goes to formation of compound. It is just imaginary, not we seen in the any microscope how reaction takes place, what is the mechanism. So it is just our logical approach will decide how reaction goes, how reaction takes place, their mechanism. So mechanism and rate of reaction also decide how these two react together and two reaches at the equilibrium point. So this is a kinetical point of view. For example, so once this is very limited because it is thermodynamic, but kinetically more helpful to understand the chemical reaction and their mechanism. Suppose we consider thermodynamical method, thermodynamical approach. Suppose we have this reaction, Ni, okay, nickel sulfate. When we add the water, so 6 molecule of water consume and formation of here NiH2O 6 SO4, okay, is the complex. It is a coordination complex. Okay, complex formation happen. This is also included in your practical. This is once complex formation. So here nickel sulfate is ionic. When you add water, they dissolve. Once they dissolve, so formation of this complex, it is a soluble form. It is a soluble. If with this react further with cyanide, Cn minus. So how many ligands here attached? 6 ligands. So we need here how many? 6 ligands are required here. So what happened here? NiCN6 SO4. NiCN6 SO4. Plus these 6 are removed out. So 6 H2O. This is the reaction. What happening here? So in first step, this is the step first. Okay. This is the first step. Here what happened? Nickel and water bond formation takes place. But in second case, carbon means Cn and nickel bond formation takes place. So here which bond is present? NiCN. And here which bond present? NiH2O. It is the reaction mechanism. Thermodynamically set of condition can't explain how this reaction takes place. It is a way of mechanism, speed of reaction, way of mechanism. So in first step, this is the equilibrium point. Okay, NiH2O6 SO4 is completely formed. But when it further react with cyanide, it forms the hexacyanonickel sulfate. Okay, hexacyanonickel sulfate, nickel second sulfate. Okay, this is the later part, how giving the nomenclature to the inorganic coordination complexes. So this bond, look at here, and this bond. The NiH2O bond is easily break by Cn minus and form NiCN bond. But if you think here again is 6H2O, is it possible this further react and come back? No. Means NiCN, also water is there, but the further reaction between them and come back to the original state is difficult. That means the NiCN bond is stronger bond as compared to this is the weaker bond. That's why H2O is replaced by Cn minus. So here, which complex is stable? NiCN6 is more stable because it forms the stronger NiCN coordinate bond as compared to NiH2O bond. Okay, so here it is the inert. It is the inert in nature. They cannot easily exchange their ligand with other ligand. So here what happened? Water is exchanged by Cn. Both are ligand. Water is ligand, Cn is ligand. But Cn ligand replaces the H2O. So that's why here is the Libel complex. Here is the Libel complex. But after once formation of this, water cannot be further replace the Cn minus and come back to the this state. Why? Because NiCN bond is stronger. That's why this is the inert. Here is the Libel. So it depends on reaction mechanism, and acidic and basic character between the metal and ligand. So this is all about the inert and liable formation. So how going to calculate formation constant? So equilibrium of formation, equilibrium of formation constant. So what is the equilibrium? Equilibrium means reaches to the initial and finally. You know the equilibrium constant depends on concentration of reactant and concentration of product. If we think about same reaction for the to express the equilibrium of the formation constant. So equilibrium of the formation constant, if we consider same reaction, NiSO4 plus H2O, 6 molecules are required, converts into NiH2O6SO4 when it react further with Cn minus. Or if you think, you just consider here NH3. We take another example. So what happened here? NiNH3 6SO4 plus 6H2O. It is the given reaction. So here is the electrophile, water is nucleophile, you know electrophile, nucleophile. So here is the metal is positive electrophilic, water here is the like a nucleophile, donate the electron, complex is formed. Here the NH3 is nucleophile and water is replaced as a living group. Water is as a living group. तुम्हाला जर inorganic पेक्षा ऑर्गॅनिक जास्त माहिती आहे किंवा ऑर्गॅनिकचं रिएक्शन मेकॅनिझम माहिती आहे, इथं SO4 हा लिव्हिंग ग्रुप नाही, तो कोऑर्डिनेटच होतो त्याशी. हा न्यूक्लिओफाइल आहे, हा इलेक्ट्रोफाइल आहे, यांच्यात रिएक्शन झालं, कॉम्प्लेक्स फॉर्मेशन झालं. इथं NH3 इथं अटॅक करेल आणि H2O ला काढेल, म्हणजे H2O लिव्हिंग ग्रुप झाला, NH3 हा न्यूक्लिओफाइल झाला आणि हे कॉम्प्लेक्स फॉर्म. सो हेयर इज अ रिएक्टंट, हेयर इज द प्रोडक्ट. Here is a reactant, there is the product. So when we consider equilibrium constant, which is expressed by K, it is well explained. The concentration of reactant, product upon concentration of reactant. So in given reaction, the product is NiNH3 6SO4 plus concentration of how many? Water. So 6. हे नाही लिहिलं, इथं 2 plus लिहिलं तरी चालेल. Plus this side we have NiH2O6. There are 2 plus, their concentration plus the second thing is here NH3. How many NH3? 6 NH3. So this is the equilibrium constant. K is equal to, so it is equal to 10 raised to 8. It is equal to 10 raised to 8. So it is the equilibrium constant. Equilibrium of formation constant. At this rate of, this is the rate of reaction. 10 raised to 8 is the rate constant, equilibrium constant. Okay. So this is the reactant, product, this one is the reactant. And you know water is present in excess quantity because in that step we add just water. So water is in excess, so we can replace. If you add more and more water, their concentration remains same. For you, if 1 liter water and 10 liter water, their concentration is same or different. You comment in chat box 1 liter water and 2 liter water. Both has same concentration or different concentration. So here we can replace this because there is no effect of their concentration on the formation because water present in excess. So we simple write here what? NiNH3 6 2 plus upon NiH2O6 2 plus upon concentration of NH3 6 power is 6 because there are 6 molecules. So this is all about the formation constant of given reaction. So K is the formation constant or equilibrium constant of given reaction. We can express using this way. And last, there are types of formation constant. Types of formation constant. There are two types. First, stepwise formation constant, and second on overall formation constant. Simple. Overall means we just think about the initial and final step of reactant and product. But stepwise means we think about each step. Means if there are 6 molecules are attached, this is the example. For example, in your book the example which is given, suppose here Ag plus NH3. What happened here? In first step there is a formation of this one Ag plus NH3 plus here is a 2. So what happened here? How many NH3 molecules are required? 2 NH3 molecules are required. Okay. So overall if we directly think the concentration of this upon concentration of this, but if we think stepwise, so in first step the Ag plus react with one molecule and formation of Ag NH3 plus, further it react with second one, then we get Ag NH3 twice plus. So here 2-step reaction. In first reaction there is a 6-step reaction, because if you think there is a Ni H2O6, okay, 2 plus how many? 6 Cn minus, right, or 6 NH3 molecule. So directly we write what happened here, Ni H2O6, sorry, Ni NH3 2 plus. It is a reactant and product, but this reaction proceed in a 6-step. First react one molecule, then react second molecule. If one molecule is react, it converts into Ni H2O5 NH3 2 plus. When second molecule is react, plus here is the H2O. Okay. When second molecule is react, Ni H2O आता 4 असतील, NH3 किती झाले? 3 झाले, plus H2O. परत तिसरा molecule react होईल. This way, first step, second step, third, fourth, fifth, sixth. So we can write the formation constant for each individual step. So step 1, step 2, step 3, step 4, step 5, step 6. So this is a stepwise. And second, overall means this step and this step. This step and this step. This is the overall formation. Means the sum of all the stepwise formation and their average is the formation constant, average formation constant, and overall means we think about the first and last step. What happened between is not expressed in the overall formation constant, but in stepwise formation constant we think about each and every step, and this way we can easily calculate rate of reaction formation constant. It is a part of the kinetics. And last point is factors affecting on stability of complex. Then we will stop. Factors affecting on stability. Okay, so once complex is stable or not, it will decide, or it will depends on different kind of factors. So here we are going to study. The first factor is nature of central metal ion. Nature of central metal atom or ion, because in complex there are 2 participants. One is metal, another is ligand. So nature of metal, nature of ligand, and another, the third one case is different, but these 2 will decide the stability of the complex. So nature of ligand means what? Suppose there are 2 metals having different charge. So if here we consider Fe2 plus and Fe3 plus, okay, Fe2 plus and Fe3 plus, both form the complex. Here is the example, K3 FeCN6, K4 FeCN6. 2 examples are given to you. In first, the Fe present in Fe plus 3 state. In second, Fe present in 2 plus state. potassium ferricyanide, potassium ferrocyanide. Which is most stable? Which is most stable? So here that potassium present, Fe present, ligand also same, means this will depends on nature of central metal ion and their size, means what is the charge to radius ratio. So if the charges increases, radius goes decreases. You know the electron are lost, the outer electron means nuclear charge increases, so outer orbital shrink inside, it goes to decrease in radius. So charge increases, radius decreases. So charge to radius ratio, which is where is the greater, that will form most stable. So here high charge, small size, lower charge, higher size. So this ratio, charge to radius ratio, is highest or more here. So Fe3 plus form most stable complex. Fe3 plus form most stable complex because here higher charge to रेडियस रेशो, जेवढा चार्ज जास्त तेवढी रेडियस कमी. आणि जर सपोज असं कन्सिडर केलं की याच्यावरती 3 चार्ज आहे, याच्यावरती 2 आहे, आता याची जी रेडियस असेल ही सपोज 1.2 आहे, याची रेडियस 1.4 आहे, सो 1.2 हेअर 2/1.4, हे आन्सर नेहमीच जास्त असणार आहे, हा रेशोचा जो आन्सर असणार आहे जास्त असणार आहे. सो Fe3 प्लस फॉर्म मोस्ट स्टेबल कॉम्प्लेक्सेस ॲज कम्पेअर टू Fe2 प्लस. When it happen, consider if both atoms are same, the charges are different. Second thing, electronegativity. Second thing is electronegativity of the central atom and ion. What is the electronegativity? It is a tendency to pull off or pull the electrons towards itself. So outer electrons attract toward itself. This tendency is electronegativity. And same example we taken here, Fe2 plus and Fe3 plus. Who is more electronegative? This one is more electronegative because here the 3 electrons are lost. That means here greater nuclear charge, and greater nuclear charge increases the electronegativity. So Fe3 plus is more electronegative than Fe2 plus. That means Fe3 plus form most stable complex as compared to Fe2 plus. So those metal ion has higher electronegativity, that will form more stable complexes. So this is about the factors affecting of metal. First is charge to radius ratio, second is electronegativity. Same thing about nature of ligand. Nature of ligand. So nature of ligand also decides the stability, and again nature has one character. First is basic character. So what is the basic character? It is the ability or tendency to donate the electron pair to the other side. Okay, so those ligand which has stronger basic character, for example Cn minus, Co minus, another side F minus. So F minus is more electronegative, so that's why their tendency to donate the electron is minimum. कारण त्याला स्वतःचेच इलेक्ट्रॉन एवढे आवडतात तर दुसऱ्याला देणारच नाही. पण Cn minus ट्रिपल बॉन्ड आहे, sp hybridized with negative charge, हे इलेक्ट्रॉन्स फ्रीली अवेलेबल आहेत टू डोनेट. C डबल बॉन्ड O हे पण अवेलेबल आहेत. So these two easily donate the electron pair. These are stronger base as compared to F minus, Cl minus or Br minus. Means they form more stable complex as compared to fluorine. And again here is a triple bond. Once this bond is formed, so here there is a back bonding, which is we will explain in different chapter, another chapter, what is the meaning of back bonding. So those ligand which has more basic character will also form more stable complex. Okay, and after that there is a size and charge ratio. Suppose you think about F minus and Cl minus. Who is strongest ligand? Who form more stable? Fluorine compounds or Cl compounds? So fluorine, charge is 1, size is smaller. Charge is 1, but -1 charge, but size is larger. So here the answer, the ratio is higher ratio, lower ratio. So in between these two, fluorine form more stable complex as compared to Cl minus. And last one is chelation property. Third one is chelation. You know chelation. What is the chelation? Chelation means it is the uh, formation of ring and ring cluster with metal and ligand. For that, suppose this is the reaction between CO2 plus ethylene diamine. How many ethylene diamine? 3 ethylene diamine. So here what happened? This is the octahedral complex. Ethylene diamine means NH2. Ethylene diamine. Okay. So what happened? Here is the formation of ring. How many rings are formed? 3 rings are formed. So if you compare this reaction with CO2 plus and NH3. So here what happened? Sorry, CO3 plus CO NH3 6 3 plus, and what happened here? CO En3 3 plus. Both are complex, both are amine related complex, but this one is most stable because when this react, formation of ring with metal heterocyclic ring, chelated complex. Here no chelated complex, here simple. Which is most stable? First one is most stable because here is all are monodentate ligand, here is the bidentate ligand, and bidentate ligand from the ring with the metal chelation. This is a chelating reagent, chelating agent. The complex is chelated complex, the process is chelation. So as compared to this simple ligands, polydentate ligand form more stable complex. So more stable without chelation. Without chelation means this is without chelation, this one is with chelation. So it is all about the today's lecture. We are going to stop here. In next lecture, we are going to discuss the nomenclature of inorganic complexes. Okay, but this is all about the formation and stability. So we are going to stop here. Then so now we start